Welcome back to Dapra's milling training video series, where we introduce important concepts for milling that will help you achieve the best performance from your cutting tools. To be successful with your milling tool, the right grade of carbide, as well as the correct cutting edge type, needs to be selected from your cutting tool manufacturer's options. This video will focus on selecting your carbide grade. First off, all milling is interrupted. Now this is in opposition to turning, where the cutting tool operation is often uninterrupted, providing a smoother cutting action. Because of this fact, it's often a very good idea to start tough with your carbide grade. Now this is the first and possibly most important guideline we can offer in regards to carbide grade selection. Now tougher inserts are softer. They'll accept shock, but they won't wear as well and won't accept significant heat. With tough grades, we generally recommend using the slower end of the speed ranges. Now harder inserts are more brittle and therefore less resistant to shock, but they provide better wear resistance and are more resistant to heat. As a result, the higher end of the speed range can be used in many cases. Here's what we have found to be a good analogy for tough versus hard carbide. The rubber ball on the left will be able to absorb being thrown into a concrete floor many times without damage, while the glass ball on the right would likely crack or even explode if treated the same way. However, the rubber ball would pretty quickly fall apart if rubbed aggressively against the concrete, while the glass ball would resist the abrasiveness of the concrete surface. Tough carbide is like the rubber ball, shock resistant but soft. Hard carbide is like the glass ball, very resistant to abrasive wear, but brittle. A good approach in most cases is to start tougher with your carbide grade so that your failure mechanism is wear rather than chipping or fracturing of your carbide insert. Wear is more controllable and predictable versus chipping and creates less potential for tool damage. As you learn what tool life can be achieved with the tough grade, gradually harder grades of carbide can be tried in an effort to increase tool life. The carbide grade description section of your cutting tool catalog or website may look something like this, with proprietary names assigned to each individual grade. Now each grade should also be shown with descriptions of its application range, either through ISO designations or through application descriptions, hopefully both. Here's some good reference information that you really should have on hand. We've included a link to this slide below so that you can print this for future reference. Tougher grades of carbide have these characteristics. They're more shock resistant, that's the toughness, but it makes them somewhat less wear resistant and less heat resistant than a harder carbide grade. A softer, tougher grade can generally take a heavier chip load or feed per tooth than a harder grade will be able to do. Tougher grades are generally used for machining softer materials below 45 Rockwell. Now on the flip side, harder grades of carbide will offer better wear resistance and heat resistance, but they'll be less shock resistant. This means that they are more brittle and won't generally take the same abuse, including chip loads and chatter, that a tougher grade will absorb. Harder grades of carbide are generally used for finishing work and for machining of harder materials above 45 Rockwell. Notice the ISO numbers indicated by each type of grade. When you refer to grade descriptions in your cutting tool catalog, be sure to note the ISO number. This number represents the hardness range of your carbide. A higher number, perhaps in the 35 to 40 range, represents a tougher or softer grade of carbide. A lower number, perhaps in the 10 to 15 range, represents a harder grade of carbide. If the catalog doesn't come right out and tell you which grade is tougher or harder, the numbers should tell you that indirectly. We hope you found this information on carbide grades helpful. Our next video will address choosing the right cutting edge for the material being machined. See you soon.